Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at how to solve radical equations that have two radicals. Now, when we're talking about radicals, of course, we're talking about that sign that's commonly associated with the square root, although it's not exclusively for that. So what we're going to do is we're going to go through a simple example and work our way up in complexity. So for the simple example that we have here, that's a little too thick. For our simplest example, imagine we have the cube root of 5x minus 4. This goes all the way across like so. Equals the cube root of 2x plus 5. Now in this particular situation, the key to success is to understand what the index is. So in this example, the index is 3. So in order to solve this particular situation, we have to raise both equations to the third power. If we do that, the cube root will disappear and we can solve it like a regular algebraic equation. So we're going to go ahead and do that. I'm going to rewrite this, put a parenthesis there, minus 4 raised to the third power equals, put my parenthesis there, 2x plus 5 raised to the third power. And so you know what happens. The 3 out here eats this 3. The cube roots are gone. The radicals are gone. And you're left with 5x minus 4 equals 2x plus 5. Now to solve this, we just do basic algebra. Nothing fancy here. So minus 2x on this side, minus 2x on this side, plus 4 here, plus 4 here. And so these cancel out, 5x minus 2x is going to be 3x, and 5 plus 4 is going to be 9. I think you know what the story is here. Divide by 3, and you're left with x equals 3. That is our answer. Again, not that difficult. What's new for some of us is how to deal with the radical. That was what was new. Now, this next example is a little bit tougher, but it's still highly doable. And so imagine we have the following. So we start with the square root of y plus 1. Notice how the 1 is on the outside of the radical. And then you have the square root of m plus 9, like so. So in order to deal with this, the first thing we want to do is we need to remove, that should be a y, y plus 9. So the first thing we want to deal with is that we need to get rid of the radical. And so we do that by square rooting. So this is what we end up getting. If I square root this and I raise it to another power, to the second power like so, I end up with the following. I end up with the square root of y plus 1, the square root of y plus 1 equals y plus 9. Now I need to deal with the magic that's happening over here on the left hand side of the equal sign. And so it's very, very simple. I'm going to work this out longhand for people who are not as comfortable with this. So square root of y becomes y. So plus square root of y, and then over here plus square root of y, and then of course plus 1. So I end up with y plus 2y, like so, plus 1. That's what I should get, equals y plus 9. So all I did was did distributive properties for that. And so now we just want to remove terms that we can remove as possible. So I'm going to subtract y from both sides. And I'm going to subtract 1 from both sides. And now I'll go to the next screen here. 2y, 2 square root of y, equals 8. Let me check that. So let's see here. Yeah, 2 times square root of y. Yes, that's correct. So 2 times square root of y equals 8. Now I divide both sides by 2 because I need to get rid of the 2. Divide by 2, and I get the square root of y equals 4. And of course, now the next step is I need to remove the radical, so I square both sides, and then with y equals 16, like so. And so that was our final answer. So you can see there are some more steps involved. The main thing that was new was dealing with this process of having to simplify the after we squared it, because we had two terms inside the square, inside the parentheses at the beginning. And so once you dealt with that, making the quadratic, you're able to deal with the other parts of the problem using basic algebra. Okay, let's do one more. This is the most complicated one. It involves a lot of steps, quadratics, formulas, and all that. And so here we go. Let's see if we can do this, make it nice and clear and neat. So here's our question, or here's our expression, if you will. So this time we got the square root of q minus 2. This is all under it, but the plus 3 is outside the radical, equals the square root of 4q plus 1. Now this is going to take a lot of work. So the first thing we have to do is we have to square everything to remove the initial radical. So we're just going to go ahead and do that like so. I'll put my parentheses there, square that, put my parentheses there, square this. So on the left hand side, I'm going to put this over here. I'm going to have 4q plus 1. That's all that's going to happen there. But over here on the other side, it's going to be a little bit messier. So now I have q minus 2, square root of q minus 2, plus 3 here, and then q minus 2. Oh, that should be a q, excuse me. Q minus 2 plus 3, like so. Okay, now what we need to do is we need to deal with all the different factoring for this. So, again, it'll take some time, but we don't want to skip steps for the beginners, people who are not familiar with this. This is based on binomial squares, but we're going to work it out longhand just for the sake of clarity. So q minus 2, when you take the square root of q minus 2 times the square root of q minus 2, you get q minus 2, and then you multiply that by that, and so you get plus 3 times this q minus 2 in the square root, like so. And then you repeat that here, so plus 3 is the same thing. And then, of course, the last part is going to be plus 9. Plus 9. So we combine like terms, so we end up with q, let me do a different color here. We end up with q minus 2 plus 6 times the square root of q minus 2 plus 9, like so. That's what we end up with. And so let me go to a new screen because this is going to take a while. So this is what we have. We have q minus 2 plus 6 times the square root of q minus 2, and then plus 9 equals 4q plus 1. And so now we can start to deal with various combined like terms. So I can, for example, I can take away q from both sides, minus q, and then I can take away 9 from both sides, minus 9. And let's see here, and I can also add 2 to both sides. This is where it gets crazy. So having done that, I'm left with 6q minus 2 equals 3q minus 6. So let me explain what happened here. I took this minus q here, and so 4q minus q gives me 3q, and then I added 2, so that'll be 1 plus 2 will be 3, and then I took away 9, so that's when it becomes minus 6, like so. So we're getting somewhere. Now, I think you know what we got to do now. We have to remove the square root again. So what we do is we square root that, and then of course we got to square root this as well. This is where it gets crazy. Now the equivalent of 6 times the square root of q minus 2 squared is 6 squared, and the square root of q minus 2 squared. So let me rewrite that. So essentially what we have is 6 squared, and then by itself in parentheses we have q minus 2 squared. It's the same thing as the term above right here. So doing that, we end up with 36, and then the square root disappears. Q minus 2 equals, and now 3q minus 6, that is going to take a little bit of work to work out. But if we had to do it over here really quick, you get 3q minus 6. 3q minus 6. Well, simply, you get 9q squared. And then you get, let's see here, minus 18q. And then again, same thing here, minus 18q. And then lastly, plus 36. So you can see this is really messy. So 36q minus 2 equals 9q squared minus 18q minus 18q minus 36. So to make it simple, 36q minus 2 equals 9q squared minus 36q plus 36. That's what we have going there so far. All right, so let's move to our next slide. We have the following. We have 36q minus 2 equals 9q squared minus 36q plus 36. Now, what do we have to do now is we need to deal with this right here. And so if we distribute that 36, we get 36q minus 72 equals blah, 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 9q squared minus 36q plus 36. Now, we just got to do some basic stuff here. We want to make this side equal 0. So I'm going to subtract 36q. I'm going to add 72. Subtract 36q. I'm going to add 72. And so we end up with 0 equals 9q squared minus 72q plus 108. That's what we have. So you're probably exhausted by now. So I can remove this 9. I can factor out the 9, which you probably can see that. And you can see that 0 equals 9q squared minus 8q plus 12. Now that's probably not so crazy. Now we got to figure out, we could use the AC method if we wanted, but we need to find a number where when I multiply it, I get 12. When I add it together, I get negative 8. And so in my mind, I'm thinking negative 6 and positive 2. And so we're getting close to the final answer here. If we work this out, we're going to get, we're still doing 0. And the answer is going to be 9. And then it's going to be q minus 6. And then it's going to be q minus 2. Which essentially means that our answer could be one of the following. Our answer could be 6 or our answer could be 2. And that is our final answer. So you can see that that was a lot of work to pull this off. But when you understand the principles that are involved in terms of solving for radical equations, you can see that we're just applying skills that we learned in the past to a slightly different context. So let me go back and try to walk you through what we've done and explain things. So we started with a simple example. The cube root of 5x minus 4 equals the cube root of 2x plus 5. In this particular situation, all we had to do was get rid of the cube root. And so we raised things to the third power because it was, the cube root. That's what it was. It was, the third root or the second or whatever you want to call it, the cube root. And so when you do that, the radical disappears and you solve like regular algebra. For the second example, what was new here was that we have this binomial, if you will. In other words, this 1 is not inside the radical, so it's a second term. And so in this situation, you had to, of course, square it, but now you have, these two binomials now that you have to work with, and you have to, figure out how to combine them and, do all those things of that nature so that you can eventually solve the actual radical equation. Again, your goal is always to remove the radicals. Remove the radicals as soon as possible, and then you can solve it using basic algebra. And so that's what happened on these two slides here. Now, for the last one, it was a much more challenging. You can see here that there's a lot going on. So I have here my radical as follows, but there are two terms inside it. That's two numbers, or two constructs inside the radical, and then we have something outside the radical as well. But then over here it's kind of the same thing. So the variety of how the numbers are constructed is much different this time. So you follow the same process, but it was much more involved because your resulting answer involves some quadratics at times. But again, if you follow all the steps of factoring things out and simplifying and all these things like that and walk your way through the process, you will get the answer. It took a lot of work, but after several slides, you can see what happened here in terms of what to do. So the best way to learn this is really just good old-fashioned practice. There is no shortcut in terms of how to learn how to solve radical equations with two terms. You have to go through it, and you have to use the prior skills that you learned in algebra in order to address these problems here. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Thank you for listening. Take care.